Hello there. Today we're going to be looking at section 7.6, radical and exponential equations, page 312, 313, and I'm going to be doing some evens from 2 to 30 in this particular section. So let's get started with number 2. We're trying to solve for the variables that we have here, in this case solve for y. So we're trying to figure out what y equals. So what we want to do is, like we would do in any other kind of a problem equation that we're trying to solve, is we're trying to get y by itself. Alright, so the first thing that we want to do then is subtract the square root of 7 from both sides of the equation. And that's just going to cancel, leaving me with 5y square root of 2 is equal to, now you can subtract these because these are both square roots, the same index and the same radicands, square root of 7. So 6 minus 1 is 5. So it's 5 square root of 7. Now, this is 5 times y times square root of 2. So if I divide by 5 square root of 2, since these are all factors, multiplication, 5's will cancel, the square root of 2 cancel, do it to both sides, and I have my answer. Now the only thing is we can't have radicals in the denominator, so we rationalize the denominator by multiplying by the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which is just 2. So my denominator becomes 10. 5 times 2 is 10. And then in my numerator, 5 square root of 7 times the square root of 2 is 5 square root of 14. Now we can reduce a little bit here. 5 goes into 5 once and 5 goes into 10 twice. So my answer is the square root of 14 over 2. And remember, you can't reduce if one thing is in a radical and one thing is not. So y equals square root of 14 over 2. Moving on to question number 4, I take a look at this and I see that I have 5x squared of 8 minus 3x squared of 2. So if I subtract one of these two terms to the other side, then I have an x on both sides, and that's not what I want to do. I want to keep my x's on the same side. I look at these two and I say, well, I can't subtract them because one is a square root of 8 and one's a square root of 2. So I'm going to have to do some simplifying here, and hopefully you know that the square root of 8 is really just square root of 2 cubed. 2 times 2 times 2 is 8, minus 3x square root of 2 equals square root of 15. Now, because this exponent right here is bigger than your index, you can divide. 3 divided by 2 is 1, so 1, 2 comes out, and 1, 2 stays under the radical. So 5 times 2, since you already have a 5 there, that's 10x times the square root of 2 minus 3x square root of 2 equals square root of 15. Now, you can see now I have both of them square roots of 2, so those will combine. So 10x minus 3x gives me 7x square root of 2 is equal to the square root of 15. Now I want to solve for x, so divide by 7 square root of 2. So this is all factored and being multiplied. And then just rationalize your denominator. Square root of 2 times the square root of 2 is going to be 2. So 7 times 2 is 14. And then numerator, square root of 15 times the square root of 2 is the square root of 30. And the square root of 30 doesn't have any perfect square roots, that's a factor of it. So that is simplified. The square root of 30 over 14. Moving on to question number 6. 6 says the square root of x plus 4 square root of x minus 8 equals 37. So I'm trying to get x by itself. So the first thing I want to do is let's go ahead and take this 8 to the other side. All right? And then I can combine the square root of x and 4 square root of x. So I got 1 square root of x plus 4 square root of x gives me 5 square root of x is equal to 45. All right? Now, trying to get x by itself, I'm going to have to divide by 5. And so I get the square root of x is equal to 9. And then to get rid of a square root, you simply square, so square both sides. And a square and a square root, they just cancel each other out. And so I get x is equal to 9 squared, which is 81. So your answer to number 6 is x is equal to 81. The next problem, number 8, instead of having radical, has an exponent. But remember, exponents really are just radicals written in a different way. So this is really saying y plus 6, and that's going to be the square root of that, plus 3 is equal to 14. So the first thing I want to do is subtract 3 from both sides. And you get y plus 6 to the 1/2 power, or the square root of y plus 6, is equal to 11. Now, how do you get rid of this? Well, you can multiply by the reciprocal of that, alright, square both sides, and the reciprocal of 1/2 is 2, and what happens when you have a power on a power is you multiply powers, so those two things just cancel, so that leaves you with just x plus 6 is equal to 121. Now, we just simply subtract 6 from both sides, and then y is by itself, so y is equal to 115. It wouldn't be a bad idea to check these every once in a while as well. So 115 plus 6 is 121, and 121 to the 1/2 power, well, that's the same thing as the square root of 121, which is 11, and 11 plus 3 is equal to 14. So sometimes you want to check to make sure you're doing the right thing. Moving on to question number 10. 10 says 3 times the square root of x plus 5 is equal to the square root of x plus 8. If you notice on this one we got a variable on both sides of the equations. We got a 3 square root of x, and then on the right side we got square root of x. So what we want to do is get our x's on the same side. So let's subtract the square root of x from both sides. And I'm also going to take this number, this constant, over to the right side. Alright, and this is going to leave me with, and I can subtract there because they're both square roots of x. So it gives me 2 square root of x is equal to 3. Now to solve for x, I would divide both sides by 2. And so the square root of x is equal to 3 over 2. And the way that you get rid of a square root is you square it. So square both sides. And a square and a square root cancel. So x is equal to 3 squared, which is 9, over 2 squared, which is 4. So x is equal to 9 over 4. And as we look at number 12, I actually have the problem written down incorrectly there, so let me change it a little bit. It's supposed to just be 4 to the 3x. 4 to the 3x is equal to 64. Now, as I look at this problem, I kind of know something about my powers of 4. I know that 4 to the third power is equal to 64. 4 times 4 times 4 is 64. So, if I already have the base of 4, and it's equal to 64, right here, then this exponent, this 3x, must equal 3. So you would say, well, then 3x must equal 3 here, and so divide by 3, and so x has got to be equal to 1. Because 3 times 1 is 3, and 4 to the third power, we know, is 64. So this one right here, you can almost do in your head mentally, if you just kind of know some of your cube roots, or some things raised to the third power. And so this one is just x is equal to 1. So sometimes look at the problem to see if you can do it mentally before you have to even really do any solving of algebra. Moving on to question number 14, we have 8 to the x is equal to 32. Alright, now I want to get a kind of an idea of what this answer is going to be like. I know that 8 to the first power is equal to 8. And I know that 8 to the second power is equal to 64. And so this says x to some power is equal to 32. So it's going to be somewhere in between 1 and 2. So I know my answer has got to be between 1 and 2. You know, maybe it's 1 1/2, maybe it's 1 1/4, maybe it's 1 3/4, but I know it's going to be between 1 and 2. So what you're going to do here is, if you can, try to get the base powers to be the same. And these, fortunately, are. 8 is really just 2 cubed, and that's to the x power. And 32 is really just 2 to the 5th power. 2 times 2 times 2 times 2 times 2 is 32. So if you multiply power on power here, you get 2 to the 3x is equal to 2 to the 5th. Now, when you have the same base on both sides, so 2 to the 3x is equal to 2 to the 5th, that means these two exponents must be equal to themselves, because you got the same base number. So then you just say, all right, well, 3x is equal to 5, and then solve for x, so divide by 3, so x is equal to 5 over 3. Now, you say, well, what is 5 over 3? Well, 5 over 3 is between 1 and 2, so that does make sense that I do have this. And if you want to change that to a decimal, you can. All right, but if you just want to leave it as a improper fraction, you can as well. So x is equal to 5/3. Moving on to question number 16. 16 you kind of look at, and it's one of these things you just try to identify. And so I see I got a 4 to the 3x here on the left side, and I know by my exponents, or rules of exponents, that 1/4 is really the same thing as 1 over 4 to the first, which if you go back to negative exponents is, think about it this way, 4 to the negative 1, because if you think 4 to the first is 4, 4 squared is 16, 4 cubed is 64, and so if you go backward, you're simply dividing by 4, so that's why 4 to the 0 is not 0, 4 to the 0 is 1, because 4 divided by 4 is 1, and then if you keep going backwards, just keep dividing by 4, and 1 divided by 4 is just 1/4. So 1/4 is really 4 to the negative 1 power. Now, again, I get the same base, so that means my exponents must be the same. So I'm going to say, well, 3x is equal to negative 1, and then solve for x. So x is equal to negative 1/3. So this problem's answer is x is equal to negative 1/3. Moving on to question number 18. In the exercises part B, they get a little bit more challenging. Here we have 3x times the square root of 5 plus the square root of 15 is equal to 9. So I'm trying to get x by itself. So I can subtract this part, square root of 15. I don't know what it equals, and it doesn't simplify. But I can say, well, 3x times the square root of 5 is equal to 9 minus the square root of 15. Now I need to get rid of the 3 and the square root of 5, so that's all multiplied, so I can simply divide. And so I need to do this, so the same thing to the right side. Now, that's what x is equal to, but I need to simplify a little bit because you got a radical in the denominator, and we're told to rationalize denominators. So I want to multiply this by the square root of 5, and do the same thing to the top. Square root of 5 over the square root of 5 is just 1, so you're not changing anything. Alright, and then you would need to distribute in the numerator. So x is going to be equal to 9 times the square root of 5, and then minus the square root of 15 times the square root of 5 is the square root of 75. And that's going to be all over. Now 3 square root of 5 times the square root of 5 is 3 square root of 25, and the square root of 25 is 5, so 3 times 5 is 15. Now, some of this will simplify. The square root of 75 simplifies, so there's a perfect square root that's a factor of that. If you think about it, it's the square root of 25 times the square root of 3, and what's the square root of 25? Well, it's 5. So that's what really the square root of 25 is. And then you can see that you can reduce a little bit here. So I'm going to split these, split this fraction apart and say, well, this is 9 square root of 5 over 15 minus 5 square root of 3 over 15. Both parts are over 15. Now I can reduce. Some books won't have you reduce. They'll just leave it like that. But I'm going to reduce because I see that I can. 3 goes into 3. Or 9 3 times, and 3 goes into 15 5 times. And here, 5 goes into 5 once, and 5 goes into 15 3 times. So x is equal to 3 square root of 5 over 5 minus the square root of 3 over 3. And you can't put those fractions back together since the denominators are not the same. Alright, so 3 square root of 5 over 5 minus the square root of 3 over 3. Moving on to question number 20. On number 20, I got 4y, and then I got a plus y square root of 7 is equal to 9 plus 3y. So I got y's on the right side over there. So the first thing I want to do is get it to my left side. And so I want to subtract it to get it right there. And that's just going to give me 1y plus y square root of 7 is equal to 9. Now, what you're going to have to do is, you got a y in both of these, so we're going to factor a y out. Okay? Y times 1 is equal to y, and y times the square root of 7 is equal to y square root of 7. That's equal to 9. Now I did that so I could make factor here. The reason I wanted to make factors is so it's all multiplied so I can divide. And that gets rid of that part and I'm left with y. Alright, you got to do it to both sides. Now, you can't have a radical in the denominator, and we teach that you get rid of this binomial by multiplying by its conjugate. So it's going to be 1 minus the square root of 7. And do that to the numerator as well. And then you're going to have, going up here a little bit, you have y is equal to, now distribute, so 9 times 1 is 9, and 9 times minus square root of 7 is minus 9 square root of 7, all over, just have to do first and last, so 1 times 1 is 1, and the square root of 7 times negative square root of 7 is negative square root of 49, and so that is going to just be 7, so this is going to be minus 7. So y is equal to 9 minus 9 square root of 7 all over negative 6. And then we would put the numerator put the negative sign in the numerator by switching all the signs and then do some canceling. Alright? So 3 goes into 9 3 times. 3 goes into 9 3 times, and 3 goes into the 6 twice, and change the signs. So we're going to get negative 3 plus 3 square root of 2 all over 2. I kind of ran out of room there, so hopefully you can see that. So negative 3 plus 3 square root of 2 all over 2. And if you're wondering why I said the square root of 2, that would be a really good question, because I caught myself. There is no square root of 2 in here. Did everything right till the very end, and I looked at that numerator. That is actually the square root of 7. So it's negative 3 plus 3 square root of 7 over 2. Sorry about that. Moving on to question number 22. Question number 20, have to think about some perfect square roots that might be factors of these numbers, because you got square root of 147, square root of 108, and those won't combine. But if you think about it a little bit, the square root of 147 is the square root of 49 times the square root of 3. And the square root of 49 is 7. So you got 2y times 7, which is 14y square root of 3. And then the square root of 108 is the square root of 36 times the square root of 3, which is 6, so it's minus 6y square root of 3. It's equal to 4y square root of 3 plus 1. Now if you combine the left side, 14y, and you can because they're both square roots of 3, 14y minus 6y is 8y square root of 3 is equal to 4y square root of 3 plus 1. We want to get this y now to the same side as the other y's, and since they're both square roots of 3, we can do that. So 8y minus 4y is just 4y square root of 3 is equal to 1. Now to solve for y, let's divide by 4 and the square root of 3. So do the same thing to the right side. Now rationalize the denominator by multiplying by the square root of 3 over 3. Square root of 3 over the square root of 3. And so y is going to be equal to the square root of 3 all over 4 times the square root of 9. Square root of 9 is 3, so 4 times 3 is 12. So y is equal to the square root of 3 over 12. Moving on to question number 24. If I'm trying to solve this one for x, the first thing I want to do is just go ahead and get that constant over to the right side here. So that gives me 5 times 2x plus 1 all to the 1/2 power is equal to 15. Next, I can go ahead and divide by 5, both sides. So I got 2x plus 1 all to the 1/2 power, or just the square root of all that, is equal to 3. Now to get rid of a 1/2, let's square it. And when we do power on power, those two just give you to the first power. So 2x plus 1 is equal to 3 squared, which is 9. Then subtract 1 from both sides, so 2x is equal to 8. Then divide 2, and so x is equal to 4. If you want to throw that in, you can. We'll just do it mentally here. 2 times 4 is 8, and 8 plus 1 is 9. And that's the square root of 9, essentially, which is 3. So 5 times 3 is 15, and 15 plus 8 is equal to 23. So again, every once in a while, check to just make sure your answers are correct. Moving on to question number 26. Let's go ahead and get our numbers to the right side. We usually take our variables to the left, and so I'll do the same thing again. And that'll cancel, leave me with negative 19. And then also, since these are both square roots of 4y minus 5, I can go ahead and combine them. So minus 2, square root of 4y minus 5. And 3 minus 2 is 1. So I get the square root of 4y minus 5 is equal to negative 19. Now, at this point, you don't have to square both to get rid of the square root, because we know that when you take a square root, there's no way you can get a negative number unless you're talking about imaginary numbers. Since we're not going to solve these equations using imaginary numbers, then we would say, well, no square root's ever going to give you a negative number, so we would just say there's no solution to this set. It's an extraneous solution. So anytime you have a square root by itself is equal to a negative number, just put empty set. There's no number that we can put there, no real number that you can put there for y that would make this true. Moving on to question number 28, and we're almost finished. 2 times the cube root of y plus 5 plus 18 is equal to 22. So get y by itself, try to isolate y. So let's take that 18 over. That gives us 2 times the cube root of y plus 5 is equal to 4. Now to get rid of that 2, we could divide by 2. And so that gives us the cube root of y plus 5 is equal to 2. Now how do you get rid of a cube root? Well, let's just cube it. And so those two things cancel. So we have y plus 5 is equal to 8. And then lastly, subtract 5 from both sides. So y is equal to 3. Y is equal to 3. If you want to check that, 3 plus 5 is 8. The cube root of 8 is 2. 2 times 2 is 4. And 4 plus 18 is equal to 22. And moving on to our last problem, number 30. 6 to the 3x minus 6 power is equal to 216. This is one where you want to try to get some similar bases, and we can here, because we know that 216 is really just 6 cubed. And since both of these bases are 6, then these exponents must be equal to each other. So we just say, well, 3x minus 6 is equal to 3, and then solve for x. So add 6 to both sides. So 3x is equal to 9, and then divide by 3, and x is equal to 3. And if you plugged it in, 3 times 3 is 9, and 9 minus 6 is 3, so 6 to the third power is equal to 216. So those are the evens on this section, at least 2 to 30. And so hopefully that helped. I know it's kind of fast, but you can always go back and review any of these problems that you didn't understand.